In this session, you will learn more about one of the most fundamental concepts in Azure, Azure Storage. We'll dive deeper into topics like Azure Disks, managed disks, and disk performance. We'll go through an overview of storage pricing, including pricing managed disks, and we'll discuss the practical differences between standard and premium storage. Understanding Azure Storage is a fundamental building block needed to start building a successful cloud practice in Microsoft Azure. Enjoy the session.
So Azure Storage, one of the types of storage that you have in Azure is called Azure Disks. Effectively, those are VHD files. So if you think about a Hyper-V environment, which obviously is the parallel to the vSphere or ESX environment, in Hyper-V environment we have VHD or VHDX files that get attached to the individual VMs as disks. So in Azure, a VHD file can be attached as a disk to a particular VM. So as an example, just to show you what that looks like, if we go to a particular virtual machine, and as you recall, we talked about, virtual machine consumes Azure compute and per minute, per second, it is paying for that compute, depending on what instance or what family of VM you're using. In order to have a VM, you must have an operating system disk, an OS disk. So let's click on any one of these VMs. So let's start with DCL1, as we've done before. One of the options here is called disks. And if you click on disks, you will see that this VM has two disks attached to it. Disk 0, LUN 0 is a data disk, LUN 1 is a data disk, and then there's also an OS disk. So in total, there are actually 3 disks attached to this particular VM. If you go under services and search for disks, you'll see that there's actually kind of a management interface for disks that I've just added to my favorites right there. This will give you a list of all the disks available in a particular subscription, resource group, account, what have you. You can limit this by certain resource group. For example, let's look at NFA 5001. So you can see that I have various disks inside of this account, and you can also see what machine they are attached to, what VM to be more specific. They are attached to. So like, for instance, the 3 disks that we looked at, one of them being an OS disk, one of them being, 2 of them being data disks, are attached to DCL1. You can also see the sizes of disks, and you'll notice that these sizes are very discrete. You don't really have in-between sizes. So you have, 4 gig, 8 gig, 16, 32, 64, etc., up to, I believe the current, I think maybe 8 terabytes or maybe even bigger now. But anyway, they're discretely sized disks. Okay, now there are 2 types of disks in Azure. The older sort of legacy type of disks are called unmanaged disks. And I'm going to not really talk about those in much detail. I'll mention them again when we talk about storage accounts. But the second, that's the more modern and the type of disks that we generally utilize when deploying Nerdio and using Nerdio is called a managed disk. And everything I'm showing you now is the result of this disk being a managed disk, meaning it appears as a resource object inside of Azure, whereas unmanaged disks appear kind of differently. There are different things you can do with the 2 types of objects. So let's click on, let's say, the OS disk of DCL1. Okay, so what do we see here? We see the resource group that it's in. We see the disk size and what type it is. In this case, it's a standard SSD, and there are other types that we'll talk about. It's currently attached to DCL1. It is stored in the South Central US region, which happens to be where DCL1 is stored. And it is not possible to attach a disk that exists in another region to a VM from the current region. So those need to be in the same place, even though in theory you can create a disk in a different region but you will not be able to use that as the OS or a data disk of a VM that's not in the same region. Okay. You can do a few things with this disk. You can, for instance, export it and make it, and when you're exporting it, what that does is it makes it downloadable. So you can actually point to the URL and download it as a VHD. You can then attach it to a Hyper-V VM locally. You can make your changes and then put it back and import it as a disk again, and then be able to use that disk inside of Azure. What it's telling me here is you cannot export a disk, meaning I cannot get a URL to point at and download it unless the VM is deallocated. So if I stop DCL1, then this disk will become accessible for me to download, but while the VM is running, it is unavailable to me. As far as the configuration goes, there's really not much to configure, but what's important to keep in mind is this stuff is grayed out right now because it is currently attached to an allocated running VM. I would be able to make these changes if the VM was not running or if the disk wasn't attached to a VM. And you can make these changes on the fly. So I could basically use the drop down and change it from a standard SSD to a premium SSD and right away power on my VM. When I power on my VM, it is going to have a premium SSD disk. However, if you think of it on the back end, it obviously didn't just magically within a second change from one storage type to another. It actually goes through kind of a background migration process, which you don't really notice. You can't really track it or see, how far along it is. Now, with each type of disk account type, so standard SSD, premium SSD, standard HDD, etc., you have different performance characteristics and estimates, and there are two metrics that are tracked, and we'll be looking at the specifics in a minute. But for standard SSD, you get up to 60 megabytes per second of throughput. So if you're doing sustained reads and writes, you can expect performance somewhere in this range. And if you're doing very small random access operations, then you have about 500 IOPS. That is your limit. And the bigger the disk, the more you get with certain storage types. With standard storage, you don't really get much more than what's here, 560. But with premium, you actually get more as you go up. So as the disk is bigger and more expensive, they give you more IOPS and throughput limits on those disks. Let's jump onto this page. That is Microsoft Azure Storage Overview and Pricing. There's probably about, 1, 2, 3, 4, 5, 6, 7 types of storage, but the vast majority aren't relevant to us at all. So let's focus on blobs, disks, and files, okay? So for those of you who are familiar with Amazon's S3, which is the first cloud storage service that came out, I think 2005, 2006, it's basically what's called object storage, where you can take discrete objects, and those may be files, and you can put them into a storage repository via some sort of a REST API or some sort of an interface. Okay, so that's what blob storage is. It is the cheapest, other than the data lake, which is long-term storage, but let's ignore that for now. So it's 0.2 cents per gigabyte per month to store things as blobs. Blobs aren't really useful in an IT context because you can't really store anything in particular in blobs without some sort of a interface into blobs. So you need, like for example, Dropbox is an interface for using Amazon's S3 object storage. So without Dropbox, you can't really leverage S3 directly. I mean, there are some tools that can let you, drag and drop things in there, but it's not very common, not very useful in the IT context. It's really more for applications. So if you think about, let's say, Trello or Asana or any of those tools that allow you to attach objects to them, where those objects actually get stored is in blob storage on the back end, because that's the cheapest It gives the provider, in this case Azure or AWS, the most flexibility on how to treat those files. They don't have to go into contiguous space, so it's cheaper to deliver, which is it's the cheapest type of storage available. The second one we talked about are managed disks, right? So it's kind of the next level of abstraction. A managed disk is something you use to attach to VMs and attach to VMs only. So whereas page blobs, or I'm sorry, block blobs can be accessed directly through some sort of an API, a disk really can't be accessed directly. A disk is basically a file in a format that a virtual machine can connect to as a disk. And that is what's typically used in an infrastructure as a service deployment in Azure, with OS and data disks being attached to it. And then the third type of storage that's relevant to us is files. Now, files, the easiest way to think about files is the ability to create a file share, an SMB, slash CIFS file share, which means something that looks like a regular file share on a Windows server, except you do not need a Windows server serving up that share. You can actually have Azure where you serve up that share, and you'll be able to use like a net use or a map network drive command right from within Windows, assuming the right storage access is available. You'll be able to map a drive to it or use it as a UNC, and it's accessible as a file share, but without the need for a file server, right? So there are two ways, let's say, to present a file share to a user. One would be to have a file server, attach a managed disk to it, set up a folder on that managed disk, share that folder, and present it to an end user. The other way to do it would be to create a file share right inside of Azure without the need for the virtual machine or a managed disk, and present that to your users. So these are the different storage types. Kind of high level. I don't even know if the type is the right term in this particular case, but you get the idea, right? It's the types of objects that you can store. Then for each of these objects or storage types, you have different levels of data redundancy. Okay, so the most basic one is called locally redundant storage, or LRS for short. So anywhere inside of the system, you'll see it referred to as LRS. And LRS is designed with 11 nines of durability. Again, this is not availability, this is durability, which means that within a single year, you have this much of a chance that you will not lose your data. And you have, one minus that chance that you will lose it. Okay, so just an interpretation of durability, kind of as an easy term. So locally redundant storage, from what I understand, is multiple copies of the data. I think it's 3 copies of each bit, of your data that's stored in a single data center. So a single physical location that is well connected. So each copy can be accessed about at the same speed from the same virtual machine, for instance. And that's what's known as locally redundant storage. Then there is zone redundant and geographically redundant. So, geographically redundant is something that we use pretty commonly. It's shorter for it is obviously GRS. You get 16 nines of durability over a given year, and you are storing, or they are storing 6 copies, 3 in the data center where you've created the storage account, and 3 more in another data center in a different region that is paired up. So there's basically in Azure, the different regions are paired up with each other. So, for any particular region where you store data, there is a predefined pair where the geographically redundant copies of the data are going to be stored. Now, you don't have access to those 6 copies, meaning it's something that Microsoft handles for you on the background. You couldn't say, well, I want to point my server or my users at a particular version, either a local version or the geographically redundant version. You don't have that flexibility. And then the final type of storage I want to talk about, or redundancy option, is called read access geographically redundant storage. Same concept as GRS, except you have access to actually decide which location you want to read from, right? So allowing you read access from the second region used for GRS. Uncommon, we don't typically use it. The two most commonly used one, I would say 80% of the time, or maybe even more than 80% of the time, we use LRS. And for certain use cases in NFA, for example, enabling a backup, when we enable backup, you get a choice whether you want to set up LRS or GRS. We may use GRS, okay? So these are the redundancy options. Now it's important to know that not every redundancy option applies to every storage type. Case in point, a managed disk can only be LRS. You cannot have a managed disk that's GRS, for example. Blobs and files, on the other hand, I believe can be either LRS or GRS. All right, so then let's keep going and look at how this is actually implemented. So managed disks are the easiest things to understand conceptually, and I showed you what it looks like in the UI. There is a disks management module, and all managed disks are listed here as what they call first-class citizens in Azure. They are objects that you can reference and work with directly, okay? Now, if you want to deal with any other type of storage type, what you have to do is create a storage account first. Okay, and the storage account is basically a repository of various storage objects. So let's go through that process. So we're going to click Create Storage Account. We get to select what subscription and resource group to put it in. We select what name we want to give it. It's important that this name, I believe, is geographically unique. That's why it requires it to be so long. No, 1 second, then on lowercase, sorry about that. Okay, so you see what this little thing is doing is verifying uniqueness. So let's click test. I bet that's not going to be unique, right? So the reason it's unique is because a storage account can be exported or presented as a URL, and it's presented as a URL. That means it has to be, you know, a unique URL for each and every storage account. That's why this has to be unique. Okay, so let's do that. Okay, that is not unique. Okay, let's try Nerdio 1, 2, 3. Okay, and again, the uniqueness has to be within a particular region, because you'll see that the URLs that get exported have the name of the region in the URL. So that's why, you know, that's got to be like that. Here you select your location. So if we, you know, if we're, let's say, in South Central, let's select South Central US. The next thing you get to select is what kind of storage performance you're going to have, either standard or premium. Up until maybe 2 months ago or even a month ago, standard meant spinning media, premium meant SSD. They've now added a standard type of SSD as well. So, you know, generally standard is slower and premium is faster. Okay, so if we do standard, you'll see that we have account types. You can do blob, you can do storage, you know, V1 or V2, and there's some differences between, you know, the types of V1 and V2. We won't get into those, but let's go with V2 because that's the latest. And then you select, you know, what they call replication or the geo redundancy, and you can select local, geo, or read access geo. And then you also get to select whether it's cool or hot. Okay, you know, again, hot means it's easily accessible and faster. Cool means they kind of stage it and put it away somewhere on cold storage, which then allows you to, you know, pay less, but it takes longer to retrieve. So let's go through the next step. Okay, do we want to be able to secure transfer? Okay, let's keep that as enabled. Do you want to allow access from specific networks or all networks? Let's say all networks. And then if we want to use data lake, let's say no. You can add tags. These are just, you know, ways of tracking and labeling things. And then the final thing is you go ahead and you create this account. I'm not going to create it because it will take a minute. I don't want to waste the time, but I'm going to show you the 2 accounts I already have. So these get provisioned by default when Nerdio is built. One of them is a premium account, one of them is a standard account. So if I click on the standard account, you'll see a bunch of options that I have here. There's something called access keys, which means I can actually export these keys and let somebody access my storage account via these keys. There is configuration where you'll see the performance, you'll see the secure transfer, the replication, etc. Encryption, etc. Now, what I want to show you here is there is a files list here, and I can go ahead and click file share, and it will ask me for a name and a quota. Okay, how much do I want to allow to be stored in here? And this will actually create a file share. Now, until I actually store data in this file share, I'm not paying for consumption because pricing of files is a per gigabyte per month pricing. So I'm really paying for what I use. What you'll notice though is I cannot create a disk directly in here because a disk is always associated with the VM and it's dealt with a little bit differently. Okay, now how is this stuff priced and how do you pay for it? So let's look at managed disks first. Managed disks come in, as I mentioned, in very discrete sizes from 32 gigabytes in premium all the way to 80 terabytes in preview right now. Actually, I think it goes bigger now. There's now 32 terabytes that you can get. And you can see that the cost of each disk is roughly proportional to the size. So you see it's roughly doubling every time. It gets a little cheaper as you get bigger, but not much. And then the throughput, you'll notice, is also increasing. And finally, it taps out at 750 megabytes of transfer, which is very fast, obviously, and 20,000 IOPS per disk. And given the size of this disk, you obviously need all the throughput. So that was premium SSD. That's storage type number one. They're called P disks, and you can see that there's P4, P6, P10, etc. Then there is something called standard SSD. Those have the letter E in front of them. They go from E10, which is 10 gigabytes, probably all the way up to 32. You can see that they're cheaper. They're about half the price. And they have slower, although not, they have about 10% at the top end of IOPS. And I forget what the other one was, but I think it was much more than that. It was 750, and here it's 500, so not much slower on throughput. Okay, so that's storage type, the managed disk number two. So there's premium, the fastest, most expensive. Then there is standard SSD, and then there's standard HDD. Okay, those have the letter S in front of them, same sizing, but you'll notice the performance is pretty flat up until a 4 terabyte, and then it starts scaling up a little bit. And again, you get similar performance to standard SSD. The difference between standard HDD and standard SSD is SSDs have a much more smaller variance of performance. So you'll almost always get something close to those maximums. Whereas with HDD, because it's based on spinning media, there's a lot of variability. So sometimes you get lots of IOPS, sometimes you won't. That's why it always says up to, as you'll notice. And with HDD, it's very true, performance is inconsistent. And then the fourth type of storage that isn't general availability yet, it's in preview, it's called Ultra SSD. You'll notice that the throughput here is quite impressive. Okay, 160,000 IOPS and up to 2,000 megabytes per second. So that's pretty good. I don't know what the pricing is. I'm sure it's going to be very expensive. Okay, so pricing for managed disk is determined by the disk size. So if let's say you have currently 512 and you go into the Azure portal and you set it to 513, you've now just automatically jumped into a 1 terabyte disk. You'll get billed for the entire terabyte regardless of how much you're using. And then you will have 511 gigabytes unallocated inside of your operating system. So it's important to remember these are discrete. But there is also something you pay for, which is storage operations. Every 10,000 or 100,000 operations, which it could be a read, the list, delete, what have you, you pay a few pennies. Obviously, if storage is very active, then that adds up. If storage is pretty dormant, it doesn't. And it's important to remember that the only storage you pay for with operations is standard storage. So either standard HDD or standard SSD, you pay for operations, whereas with premium or ultra, you do not pay for operations. Okay? Now, so managed disks, again, come in discrete sizes that you pay for based on those two metrics. Files and blobs are billed on a data usage type of a scenario. So you either pay 6 pennies per gigabyte in LRS, 7.5 for ZRS, or 10 for GRS. And then depending, so you're not paying for a preset amount, you're paying for, as you keep adding files, you're paying on per gigabyte increment. And then you're also paying for operations. And here's your costs. For LRS, you're paying 1.5 cents per 10,000 operations, 1.8 and 3 cents. And then you can also see that there are different types of operations that, have different prices. And that is it as far as files go. Okay, so again, you publish a file share, you can place files into it, and then you pay for consumption and for the operations that, that you consume.